This lesson is on polynomials. So there are quite a few definitions with this section here on polynomials, and I do want you physically writing these definitions out here in your notes. The first thing you'll notice with polynomials is you'll see what's called a monomial. And that's a number, a variable, or a product of numbers and variables with whole number exponents. So I have an example here of what monomials would look like and non-monomials. So notice we have just a number, we have just a variable, or you can combine a number and variable together. Notice on the non-monomials, we have exponents here. We have negative decimals with a negative exponent. We have subtraction of variables and division of situations. So with monomials, you're just have either, like the definition said, a number, a variable, or the product, meaning multiplying numbers and variables. The degree of a monomial is the sum of the exponents of a variable, meaning you're going to add the exponents of the variables together. And a constant has a degree of 0. A constant is just a number without a variable. So I can put number, a constant is a number without, a variable. Polynomial is a monomial or a sum or difference of monomials. The degree of a polynomial is the degree of the terms with the greatest degree. So we'll do some examples here with degrees of a term dealing with the greatest degree. We have standard of a polynomial, which contains one variable that is written with the term in order from greatest degree to least degree. And then when you're written in standard form, the coefficient of the first term is called the leading coefficient. So remember, a coefficient is a number in front of a variable, your first term, and we call that the leading coefficient, the first term with a coefficient in front. So here we have a chart that shows some polynomials that have special names based on the degree and the number of terms they have. This is really important here for when you're naming polynomials based on the degree and the terms. So if you have a degree of 0, it's a constant. 1 is linear. A degree of 2 is quadratic. 3 is cubic. 4 is quartic. 5 is quintic. 6 or more would be like 6th degree, 7th degree, and so on. And then when we're looking at your terms, meaning how many terms there are, monomial would be 1 term, 2 terms is a binomial, 3 terms is a trinomial. And then when you have 4 or more terms total, then we call that an overall and general polynomial. Remember, a variable without a coefficient has a coefficient of 1. So looking at this situation here, we have y to the 5th, which means the same as 1y to the 5th. So when there's no value in front of the variable, then the coefficient is just going to be 1. Let's do some examples here, and they want us to find the degree of each monomial. So looking at A, we have 1.5k squared m. So what you're going to do first is you're going to look and see how many degrees there are. Well, there's a degree of 2 for the k, and m has nothing, so we'll just say 1. So what we do is we add those 2 exponents together, and the total degree of this is going to be 3, because 2 plus 1 is 3. And as it mentioned, we do add those exponents to get the value 3. Looking at B, we have 4x, and we have to determine which degree this would be. And when we look at this, the degree is going to be 1 because x has no exponent, so when there's no exponent, it's automatically 1. And we add the exponents of the variables, and since we only have one variable, no exponent, it'd just be a variable 1. Here we have 2c to the third power, so our degree here is going to be 3, because c is raised to the third power. Again, we think of adding the exponents of your variables. You just have one variable with an exponent of 3, so your degree here is going to be 3. Here we have find the degree of each of these polynomials. So for a, we have 5x minus 6. So what we're going to do first is we need to determine how many degrees each situation has. So 5x has a degree of 1 because there's no exponent with the variable. And then that minus 6, since there's no variable connected to it, that would be a constant with a degree of 0. So what we need to do here is we need to find the degree of each term, and then the degree of the polynomial is going to be the greatest degree. And the greatest degree with this situation here is 1. So the degree of a is going to be 1 right here. Let's look at the next situation. There's a little bit more involved here. We have x to the third y squared plus x squared y to the third minus x to the fourth plus 2. So what we need to do is we need to separate each situation and find the degree. So x to the third y squared, we add those exponents to get a degree of 5. X squared y to the third, that's also adding to get a degree of 5. Negative x to the fourth has a degree of 4. Since we only have this as by itself, look at the exponent, there is 4. 2 there is a constant, and when you have a number that stands alone without a variable, that would be a degree of 0. So looking at these, which of them find the degree of each term? We've done that, and then we have to find the greatest degree, and the greatest degree, looking at all this, is going to be 5. So that is going to be my answer for B. Greatest degree is 5. Here we have an example where it says, write each polynomial in standard form when given the leading coefficient. Remember, when it's in standard form, you have to put the degrees in order from greatest to least. So the notes just mentioned, find the degree of each term, then arrange them in descending order. So here we have 16 has a degree of 0. Negative 4x has a degree of 2. X to the fifth has a degree of 5. 9x to the third has a degree of 3. So what we have to do is put them in descending order based on the degree. So x to the fifth is the greatest. Then we have 9x to the third, that would be the second. Then we have negative 4x squared, that has a degree of 2. And 16 would be the lowest because that's a constant with a degree of 0. So my final answer here, the standard form would be x to the fifth, 9x cubed, minus 4x squared plus 16. And the leading coefficient, which is the number in front of the variable, the leading coefficient, since there's nothing in front of x, it's going to be 1. And that would be the answer here for example number 3. It says classify each polynomial according to its degree and number of terms. So looking at A, we have 1, 2, 3, 4 terms, and we have to find the degree of each. So we have degree is the third because 3 is the greatest degree out of each situation. And since there's 4 instances here, degree of 3, term would be 4. So the name of this would be a cubic polynomial. Looking at 6, we just have a number by itself. We call that a constant. So it has a degree of 0. One term, the term is 6. So this is going to be what we call here a constant monomial. 6 is a constant monomial. For C here, we have negative 3y to the 8th. I apologize about that interruption when solving for C here. But as I was mentioning, we had negative 3y to the 8th plus 18y to the 5th plus 14y. We have three different terms here. The greatest degree is 8, so we call this degree 8, three terms. So the name of this is going to be the 8th degree trinomial. And that would be your final answer here for C. As I mentioned, B is a constant monomial because we just have the term, but no degree. And that is the end of our notes for this section. And I hope you took good notes and wrote everything down. We'll cover this in class tomorrow when I see you.